For this problem, we're going to find an expected value given a profit and probability table. The game is described up here at the top in the statement, but for those of us, including myself, who may not know this game, I'm glad that this table is included. So I've clicked on the icon. Here I can see the profits. This would be those random variables that can happen, and their corresponding probabilities. I can open up this table in StatCrunch, and I'm going to work with this here. Turning back to the text real quick, this is coming from section 6.1. It references expected value, and it tells us here that finding expected value is the same as finding the mean of the random variable. So I'm going to go back one objective, and let me scroll over one page, and here we have this formula for finding the mean of a discrete random variable. Notice I'm going to take x, these values of the random variable, multiply them by their corresponding probabilities. I do that for each row in my table, and then I'm going to sum those together. So that's what eventually I'm going to do over here inside of StatCrunch. And there are a couple of ways I could go about doing this here in StatCrunch. In one of the previous videos I have posted in our Chapter 6 playlist, I discuss how you can go to Edit, Compute, and build an expression. But for this one, I want to show something a little bit different. We're going to go to Stat, Calculators, and Custom down here at the very bottom. And here we're going to take the values, those are those x values of the random variable. They're listed as profit in my table. And we're going to think of the probabilities like weights. Okay, so I'm going to select probability for where the weights are, and then I will compute. And out of all this information presented, only thing I really need here is the mean. The mean of this custom calculator is the same as the expected value. So that's telling me about 10 cents is lost. So if I come back over here to the problem statement, that's why you notice that there was already a negative symbol in front of where you're typing in your answer. So I would not want to include that twice. But effectively, I can think of this as on average, I would lose 10 cents playing this game. If we play this game over a long period of time, and each hour we play 35 hands per hour, what we're going to do is now think of this as a multiplication problem of I'm playing this game, on average I'm losing 10 cents per game. Multiply that by the 35 hands per hour, multiply that by the 4 hours. And so 0.10 times 35 times 4 is 14. Again, because the expected value was negative to begin with, we're expecting a loss over this longer period of time.